Hi everyone, in today's lesson we're going to talk about systems of linear equations. A system of linear equations is a collection of two or more lines. So if you take a look at this example, we have one line going this way, we have another line going this way. And if you take a look at this example, we've got two lines going in the same direction. So a solution to a system of equations is the point of intersection between the lines in the system. So here, the point of intersection is right here, and we can name that point. We're going to go over 2 and up and down nothing. So this point of intersection would be 2, 0. Now, in this scenario here, the lines never intersect. So since they never intersect, that means there's no solution. So this leads me to the different types of solutions. We won't worry so much about the definitions and the names, but let's talk about the pictures. So like we said before, we could either have no solution when the two lines are parallel and never intersect. We could have one solution if the two lines intersect at one spot, or we could possibly have what's called infinitely many solutions. So the two lines could actually lie on top of each other. So they're the same line. So what that would mean is if we have this line, say here in red, and then I put a line on top of it, all right, every single point in blue would match up with every single point there in red. Therefore, if I were to continue this pattern forever, there would be infinitely many solutions. So what we're going to work through today is how to solve these systems algebraically, where I'll get no solution, one solution, or infinitely many solutions. So the directions are simple. I want to solve each system of linear equations algebraically, and there are three ways that we can solve. Method one is called setting the equations equal, and we do this when both equations are set equal to y. So if they're both set equal to y, we can set them equal to each other. So negative 1/2 x plus 10 equals 4x minus 6. So we need to get x's to one side, numbers to the other. So I'm going to choose to add 1/2 to both sides. And we get 10 equals, now you can put this into the calculator, 4 plus a half. I'd prefer it to be in an improper fraction rather than 4.5. So that is 9 over 2x and then minus 6. And then we just add 6 to both sides. And we get 16 equals 9 over 2x. Now, to get x by itself, we can either divide both sides by 9/2, or a faster way, which I like to do, is multiply by the reciprocal. Reciprocal means to flip the fraction. So we can multiply by 2 over 9. So when you play with the right side, the 2's cancel, the 9's cancel. You're left with x equals 32 over 9. So what you just found is one of the coordinates of the points of intersection, right? Let's just say we had one line that looks like this, another line that looks like this. The point of intersection is 32 over 9, comma, something. So we need to find the other value to make it a full point. So the way that we do that is you simply plug into either one of the two original equations. So plug into original, maybe any original. So I'm going to choose to plug into the top one, or actually, no, I think I'm going to choose the bottom one. Bottom one doesn't have a fraction. It's probably a little bit easier to solve. So y equals 4x minus 6. So I'm going to plug in 32 over 9 in here, minus 6. So to simplify this, all you're going to do is put this into the calculator just the way you see it. Take a minute, pause the video, try it out, and then hit resume when you're ready. All right, so I got 74 over 9 as my y value. So to put it back into the point, 74 over 9 is my final answer. So the solution to this system is 32 over 9, comma 74 over 9. Now, I'm not going to ask you about this, so don't stress too much about that. Just know that it has one point of intersection. All right. Another method that you can use is something called substitution. And we use that when one equation is already solved for y equals and the second is not. So you can see here that y equals 3/4 x minus 4. And what we can do with the substitution method is take this y equals and throw it into this y that's right here. So we start with the 2x plus 4y equals 24. And instead of y, we're going to put what it's equal to. So we've got 2x plus 4 times y, which is 3/4 x minus 4 equals 24. So all I did was substitute this y into this spot using parentheses. And now we're going to simplify. So we have got 2x plus distribute, distribute. So in the calculator, 4 times 3/4. Pause the video, see what you get. You should be getting 3, so 3x. And then 4 times -4 is -16, which equals 24. If you combine like terms on the left side, you get 5x minus 16 equals 24. We can add 16 on both sides. So we get 5x equals 40, and divide both sides by 5. X gives us 8. And then the second thing we can do to find the coordinate of y is we can plug x equals 8 into any of the two equations on top. I'm going to choose the simpler one, so I'm going to plug it into y equals 3/4 x minus 4. You can choose the bottom one. I just choose the top one because it's already solved for y equals. So y equals 3/4 x minus 4. I'm going to plug in 8 in for x and subtract 4. Take a minute, plug this whole thing into the calculator just the way you see it, and then hit resume when you're ready for the answer. All right, I got 2. So my final answer is a point, right? It's a point of intersection. So 8 is x and y is 2. So final answer is my coordinate point. So again, the solution to the system of equations is 8, 2. Again, we don't have to do this part, but we're just going to say that there is one point of intersection. All right, so the last method that we can use to solve systems is called elimination. And we use elimination when the variables are on top of each other. So we've got x on top of x, y on top of y, numbers on top of numbers. So this method is basically you want to look at the letters that you have and you want to be able to cancel one of them out, aka eliminate. So there's a nice little trick that we can use. We can multiply the entire top equation by this number in front, and we can multiply the entire bottom equation by this number in front. So basically, this is going to get a 3, and this is going to get a 5. So by switching the values in the front, you're basically getting 3 times 5, which is 15, and 5 times 3, which is 15. And then the goal is going to be to cancel them out. So in order to cancel them, one of them has to be negative. So it doesn't matter which one it is. I'm going to choose to make the top one negative. But the goal when doing elimination, when you flip the numbers, you have to make sure, like I said, one is negative, one is positive. And then we're going to distribute this -3 to the 5. So -3 times 5x is -15x. -3 times 4y is -12y. -3 times -30 is +90. And then we'll do the same thing with the bottom. 5 times 3x is 15x. 5 times -9 is -45y. And last but not least, 5 times -18 is -90. So now that you distribute everything, you can simply add these two equations together. So the first spot, -15x with +15x will cancel. Then the second one, we have -12y plus -45y. Feel free to put that into your calculator. And if you do, you'll get negative 57 y equals 90 minus 90, which is 0, or 90 plus negative 90, which is 0. So to solve, all we're going to do is divide by negative 57, and we get that y equals 0. So again, we need to find the x value. So you can plug the y this time. So plug y equals 0 into any original equation. So I'm going to choose the top one just because it's the first one there. So 5x plus 4y equals negative 30. So 5 times x plus 4 times 0 equals negative 30. 4 times 0 is just 0. So 5x equals negative 30. I can divide by 5 and get x equals negative 6. So these two, if you put them together, are my answer. So remember, x comes first. So negative 6 comma 0 is my solution to my point of intersection, right? I've got one line here, one line here. Where they intersect is going to be the point negative 6, 0. So again, you don't have to answer this part, but you could just say that the solution is negative 6 comma 0, and there's one point of intersection. Okay, so for homework, I would like you guys to try this concept check here, and we will go over it in class tomorrow. But you must try it to get credit for your homework. All right, have a great night, everyone.